Hi everybody. In this video, we're going to look at how we can model real-life situations using curved graphs. We'll work through two examples, and if you want to work along with me, you can download this PDF from my website. I'll leave a link in the description below. So for our first example, we're told that a toy rocket is launched vertically upwards from ground level, and its height in meters after t seconds is given by this quadratic equation. For part A, we need to plot the graph of height against time from 0 to 6 seconds. And I want to show you how we can work out these values of h using the table mode on our calculators. So if we go to our calculator, we go to home, and then we go down to table. And now we need to define this function. So we press tools. We want to define f of x. This is defining h. And we're going to use x in place of t. So we enter 18x minus 3x squared. And we'll execute that. Now we can define our range. We press tools. We want the table range. We want to start when t is 0. We want to end when t is 6, increasing by a step of 1 second each time. We'll execute that, and you can see we've got our values of h. When t is 0, we've got h is 0. When t is 1, we've got 15, 24, 27, and so on. So we can enter these into our table. So when t is 0, h is 0. This will go at the origin. And this tells you that the rocket starts at ground level. Then when t is 1, h is 15. When t is 2, h is 24. When t is 3, h is 27. We get 4 and 24, 5 and 15, and 6 and 0. This means that it's returned to ground 6 seconds after it was launched. So to plot the graph, we join these points together to make a smooth parabola. Now we've been asked to use our graph to estimate the times when the rocket reaches 20 meters above ground level. So we're looking at when the height is 20. So we draw a horizontal line when h is 20, and we notice where it intersects the curve. This is at this point. We go down to the time axis, and at the other point on its return to ground. So you can see it's 20 meters above ground level when t is 1.5 and when t is 4.5. And for part B, determine the total time the rocket stays at least 9 meters above the ground. So we use our vertical scale. We find when h is 9, we go across to our curve, and from this moment in time onwards up to here, you can see we're above 9 meters. So we can draw another horizontal line when h is 9, and we need to find these two times. So we've got one here and another one here. This value of t is approximately 0.7, and this value is approximately 5.3. So the length of time that's above 9 meters will be the 5.3 take away the 0.7, which gives us 4.6. So it's above 9 meters for approximately 4.6 seconds. In example 2, we're told that a delivery van makes a 100-kilometer trip, and the amount of fuel used, F liters, at speed v kilometers per hour is given by this model here. And we're told that v is measured in tens of kilometers per hour. So when v is 3, this means 30 kilometers per hour. And we're told this ranges from 10 kilometers per hour to 80. For part A, we need to complete the table and plot f against v within that range. So do you want to give this question a go yourself, using your calculators to complete the table, and then try and interpret the graph from parts B and C? You can pause the video and come back when you're ready. Okay, so welcome back if you want to go. If we go to our calculators, we can input this function. We've got x squared minus 2x plus 3 plus 1 over x. And we can define the range starting at 1, ending at 8, a step up 1, and we'll execute that. And we've got our values for the amount of fuel here. So I'll enter this into our table. And now we can plot each of these coordinates on our grid. When V is 1, the fuel is 3. When V is 2, F is 3.5. And then we've got 3 and 6.3, 4 and 11.25, 5 and 18.2, 6 and 27.2, 7 and 38.1, and 8 and 51.1. And then we can join these points together to make a smooth curve. So that's our graph. For part B, use the graph to find the speed V at which the van uses 20 litres of fuel for the 100-kilometre trip. So when F is 20, we go across to our curve, and then we go down to find our speed. And this works out at approximately 5.2. But now we need to use our scale, so we need to multiply this by 10. And then for part C, the van must use less than 40 litres. Use the graph to find the range of speeds at work. So we go across from 40 to the curve, and then we go down and we get approximately 7.2. So when our speed V is less than 72 kilometers per hour, for the 100-kilometer trip, we'll use less than the 40 litres. Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the worksheet from my website, mrmathematics.com. I'll leave a link in the description below.